In this video, we're going to branch out a little bit. We're going to start with the basic galaxy that we worked with previously. And if you haven't seen this particular galaxy, there's some other videos on how to create a galaxy. This is the basic galaxy we started with, and this is if you've completed the course that I have. If you haven't done that, you might want to go do that now. It's archestrabasics.com, and there will be a link on this video to that course. Then this would show you exactly where we are as far as this galaxy and tutorial 1. So what we're going to do now is in tutorial 2 is we're going to advance and we're going to expand on this a little bit, create a second platform, and then we're going to use a Modbus simulator to connect to a register in a Modbus slave. Okay, so the first thing we're going to do is looking here. I'm using Oracle VirtualBox for my second machine, and this is free software. It's you can just Google VirtualBox. It's put out by Oracle, and you can download this. Literally, it's just a virtual machine. VMware is another similar product. This one is free. So once I got VirtualBox loaded, I created this platform 1 and 2 computer. Now my platform 1 computer is operating with Windows 7 64-bit, and then once I get it running, you can actually see it here as another computer. And the other thing I installed on this virtual computer then was I actually installed Wonderware, and I installed the DAS MBTCP. So once you've installed DAS MBTCP, you can see in the SMC or the System Management Console, there will be an option for DA Server Manager under Local, and you'll see that here is our Archestra DAS MBTCP. And under Configuration, we'll just walk through these real quickly, but I used all defaults, and essentially I just added a TCP IP port object, and then I added from there a generic Modbus PLC. Now the computer name that I'm using for my GR node is Charles-PC. So that's the number we'll go for the network address for this communication. That's where I'm going to run the simulator from. And the port number I'm going to be accessing the Modbus simulator is going to be 502. So I'll show you in a bit how this works. So the first thing, also under device groups, we're going to add one called PLC1. So that's what we've actually done over on the platform computer. All right, now the other thing we're going to be using is the Modbus PLC simulator, which is I think the best one that's free, is plcsimulator.org. This is a free Modbus simulator. I have actually also created some connectors which we'll go into later on how to make this simulator more compatible with the DAS MBTCP for Archestra. So now let's go back to the galaxy. So the first thing we're going to do is we're going to go over to our derivation view, and we're going to add a new platform. So right now all we have in this galaxy is a GR platform. So we're going to create a new platform, or a new instance of the Win platform template. Notice it's got a red X in there because it hasn't been assigned to any platform yet. So we're going to go ahead and double click there, and now what I did, if you'll go over, so if I go back to my virtual machine, this machine name, this will also tell you the name of your computer here, Platform 1. So Platform 1 is the name of this computer. So we'll go back to the galaxy, and we'll type here Platform 1. Okay. And then if I wanted to put a comment for save, I just could say created platform. And so now it should be, we can go to deployment view, and you see now under GR I have a new platform called Win Platform _001. That's just the default name. You can call this anything you want. And we can then do a deploy. Okay, and once it's deployed, you can see the difference between the way these platforms look. This one has a gold tint because it's the GR. It's the only one that'll be colored that way. These other platforms all have a silver tint, and any subsequent platforms that are created will have that same color, so that you can immediately see which is the GR and which is a deployed platform. So the next thing we're going to do is we're going to start populating this platform. So I know that I'm going to want an app engine, so I'll go up here to the app engine master template, and I'll create a new instance. And I also am going to need an area, so I'll go here and create a new area instance. And then we're eventually going to need another view engine, so we'll go ahead and do that as well. And up here, so under tutorials, I'm going to go ahead and create a new derived template called tutorial 2. And from this we will actually create our new InTouch application for tutorial 2. I'll go ahead and create an instance of it so I can deploy it. So now that we've done this, let's go back over here. We'll start building out our platform. So the first thing we're going to do is we're going to drag our app engine from the unassigned host area. So all of these objects I've created are now in the unassigned host folder, so they need to be assigned. So we'll just drag them and drop them where we want them to be assigned. So there's my app engine. I'm going to put my area on the engine. Now I need a view engine. I'm going to put that on the platform, and I'm going to bring the view app down to the view engine. And there we go. And now the next thing we're going to need are objects. So we're going to go to the user defined template, and we're going to create a new derived template, and we're going to call it signal. And from this we'll derive our signals. So the first signal we're going to create is another derived template for analog input, and this is integer. So these are going to be analog input integer objects. So we'll go to the template, we'll go ahead and open it up, and let's create an analog attribute, and we'll call this PV. It's going to be an analog integer, and here I'm going to put this dash 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 placeholder, which allows me to leave it empty, which is a valid empty reference. So then we've saved that, so we now have an analog integer object template. So I'm going to create a new instance of that, go back to deployment view, and then drop it onto my area. Now let's go ahead and deploy these, and I can actually go to the platform and deploy, and if I say skip and cascade, it'll deploy everything underneath that platform without redeploying the platform. It'll skip already currently deployed objects. So let's okay, so this is fully deployed now. Now let's go over and set up our simulator, and then we'll come back, and there's some more work we have to do in here. But first let's get the sim running. So the simulator, ModSim, is a very simple program. You just download it and run it. And it's got a lot of different features. But for right now, all we're going to worry about is that we're going to make sure that the port setting is 502. And that's really all we need to worry about right now. We're going to actually be using this register, which you'll see is 400031, and I'm going to put a value of 55 in there. Just put a value of 55 in there. Just remember that. Okay, so now we're going to go back to the Galaxy. So let's head back over to our remote computer, and I'm going to run Task Manager. So I want to show you something. Okay, so we run Task Manager, and if you look in here in your Task Manager, you'll see -mbtcp. That is the name of the running executable for this guy right here. The -mbtcp is very important. We'll need that information to communicate with this any objects deployed on this platform. So the next thing we'll do is we'll go back then, and now we need to create a connector for that Modbus simulator to connect to any Modbus device. Let's say the simulator was a PLC. So the next thing we're going to do, back to the derivation view, and now we're going to look for our DDE SweetLink connector. So let's go ahead and create an instance of that, and I'm just going to leave it named its default. So I'm going to go ahead and bring it down to my engine. Now DDE, these DIO objects, these are device integration objects. They're very special objects. They're very similar to, they have engine properties. You drop them onto an engine. You don't drop them onto an area. So the next thing, because it has the red X, it tells me it needs information. So I'm going to go in here right now. Server node, this is going to be platform 1, because that's where the DDE, that's where the dash MBTCP server is running. That's where our communications server is running. And the server name is dash MBTCP. And how do I know that? Because I got that from the platform, because that's what's in the task manager. That is what's actually exposed as a executable name at runtime. So that's the server name that we want to communicate with, is dash MBTCP. And we're platform 1 is where we're going to be connecting. So we'll go ahead and save that. Oh, excuse me, I forgot. I need a scan group. So this will need to match the device ID group that I have over there, which I call that PLC1. So we just call that PLC1. Now we can close and save. And let's go ahead and deploy. Okay, so now that we have our DDE SweetLink client deployed, let's use the object viewer. So you right click on this guy and go to View in Object Viewer. And the object viewer is an incredibly important tool for Archestra diagnostics, because it shows you, and I've covered this in previous tutorial, how this thing, what's going on in the galaxy. So this is going to browse into our DDE SweetLink client object, and we need to determine if it's connecting to our dash MBTCP server that we have running over on the platform. This should resolve out. It's a little slow, so you can actually go ahead and browse in if you need to. So let's go to the App Engine 2, and here's our DDE SweetLink. Now, what we're looking for is the connection status, and you'll see that it is connected. I'm going to go ahead and drop this down into the watch window so that I can get a real-time update of it. Okay, there it is. So we now see that it's showing connected. Okay, so now the next thing we want to do is we're going to go back to our derivation view, to our analog input register, and let's go ahead and take a look at that guy. So now we're going to fill in the actual address to the input source. So here's our analog input integer object. It's looking for an analog input integer. So we need the name to get a path. So we need the name of this guy. And a quick way to do that is just to hit rename and Control C, and then you can just do a Control V and paste that right in there. Put a dot field on it, and then when the name of our topic here, and then the address we're after, which is 400031, which has a 50 in it. Okay, so let's go ahead and save that and deploy. Okay, so if we did everything correctly, let's go to Object Viewer now with this guy. And we're going to take a look in that. We should see 50 in our PV if everything is working correctly. It did resolve, and there it has 55 in there. The 55 is the value that we had put in our sim. So now, if everything is working correctly, let's go back to our sim and let's change that value. Let's go ahead and make it 75. And we should see it update there in our window, and there it did. So we are now connecting to the object that's deployed over to the other platforms. If you go over to the other platform, you'll see under diagnostics we have one register connected, 40031. It's currently a 75. So now what we have proven is that we have deployed this analog integer input object to this remote platform. It is connecting to the DAS MBTCP, which is configured to read back actually to a simulator running on the GR node. But this could be running anywhere. It's wherever we told it. In this case, we told it Charles PC port 502. This could easily be another computer where I have a PLC running. So currently, let's say if I had a PLC, a Modbus PLC, I would probably put the Ethernet address, the static Ethernet address here where it says Charles PC. And then you need, typically default port for Modbus is 502, but this could be any port that you have configured on your RTU or your PLC. Let's go ahead and create something in our view app, so that a graphic, so that we can view this information. Just something really simple. So we're going to go ahead and create a new graphic toolset called Tutorial 2. And in Tutorial 2, let's just create a real simple graphic. So new symbol, and we'll call this read integer, just for let's draw a window and then use some text. And I can center this inside there. Let's go ahead and make this bold, up its size a little bit. Make sure it's centered. Okay. So really quickly, we'll just create an animation here for analog, for a value display. It's an analog, and I think it's just we're gonna say me.pv. So now we need to assign this symbol to an object. Alright, so now I'm going to create a new symbol called container. And in the container, I'm going to drop this one in here. So now I have read integer 1. And here I'm going to create a property called owner, which is going to be a string. Okay, so analog input integer 001. Alright, so let's review real quick. We've created a read integer symbol. We dropped it into our container. We created an owner property. We're now going to create a data change script called set owner. It's going to, on the owner property, I'm going to do a data change, so it'll run every time this thing shows up. So now we're going to look for our read integer. The owning object is going to equal whatever object is in owner. There you go. Alright, so now save that, and we're going to go to our view app. Okay, now we're just going to create a test, call it test integer. Okay. And then we're going to import. Now we're going to import the container, because that's what's got our, okay, let's double click on this guy. We'll see there's our owner. Okay. Now we'll close this. You'll notice that it's dirtied up. In other words, it has the black yellow diagonal box. Let's deploy that change. Alright, so then we'll go back over to our remote computer, run the InTouch Application Manager, and there we have Tutorial 2 is deployed. Let's run it. Alright, yes, it's changed. Let's see what we got. Test integer. 75. Very good. All right. So now if I go and back to the main computer, and let's change the simulator now to, I have this scaled 0 to 100. So if I try to go over 100, it's going to clamp at 100, I believe. So if I put 110 there, it is going to put 110. Okay. Maybe I didn't scale it. Okay, 30. So what we've done here is we have, let's review then, recap. So go back over to the Galaxy. We have created a second platform object deployed to a remote computer that's running a -MBTCP Modbus data server. We created an app engine, an area, and a new object called the analog input integer object, which is basically just set up to communicate. I created a PV. This is the path. We created a DDE Suite Link client, which connected to the -MBTCP server with a topic of PLC1. And if you go back over here real quick, the remote computer, let's go look over here at our configuration here. You see device groups, PLC1. All right. So device groups, PLC1, and then topic, PLC1. That has to match. So your device group on your DAS-MBTCP must match the topic name on your DDE Suite Link client. We then created, okay, this PV, and I did not enable scaling. That's what I was talking about a minute ago. So if I wanted to enable scaling on this, I could just come down here, and then it's default at 0 to 100. So let's go ahead and do that. And every time you make a change, obviously you have to redeploy. So let's deploy that change. All right, so then we came up to our graphic toolbox. We created a read integer. And like I said, there are numerous ways to do this. I'll show you some other ways to do this, but literally all I did here was created a rectangle, a text object, attached an animation to the text object. It's a value display of me.pv. So me.pv says that me, whoever your owner is, there's going to be an attribute called PV. And that's exactly what we did. If you look down in the analog integer object, we created this UDA. It's an analog UDA called PV. And this is a special, it's a field attribute UDA. It's of type analog and integer. So PV is the UDA name. That's the attribute name. So analog input integer _ 001 dot PV is what we're actually connecting to. And that becomes apparent up here then. So when I say me.pv, that means whatever object I assign to it. So then we took this guy and we created a container object that we could then drop the read integer into. And now we can assign an owner. And we went into a script that on data change, it says read integer owning object equals owner. So that's what assigns this symbol to an owning object. And like this is a direct way to do it. There's an indirect way to do it using custom property, which is what we did in tutorial 1 when we do the set property. You can actually assign an owner remotely when you instantiate a new symbol, or you can do it directly, which is what we're doing here by creating a containing object. Then we took that and embedded it into a view app by double-clicking the view app template. It pulls up an instance of window maker inside the IDE, and we created a window, and we just dropped, using embed Archestra graphic, the container onto a window. And then we just made sure that it had analog input integer _ 001. So whatever name here is the owner of this symbol. And that's the value of PV that it's going to show. And that's all we did there. Okay, so that's going to wrap up this tutorial 2 where we extended the Archestra Galaxy. Now, the next tutorials we're going to get into a little more detail, and I know I breezed through the Modbus simulator setup, so I'm going to do one specifically on downloading the Modbus simulator, some of the features of the Modbus simulator, and how to use it better with DAS MBTCP and how you can customize some of the options. So I do appreciate your time, and I'm doing these things for you guys. So if there's something that you're wanting to see that I'm not picking up on, let me know. Give me some comments, and if you find value in these, then go ahead and subscribe to this YouTube channel and give me a thumbs up. Now, if you want more, you can head on over to orchestrabasics.com and check out the course that I have there. And I'll be adding more courses there as we go. I'm gonna add some specifics on Modbus, how to use the Modbus protocol. As a matter of fact, I think I'll probably do some on troubleshooting Modbus as well, because Modbus, there are a lot of PLC types and a lot of RTUs and a lot of different protocols. Modbus is very common, and so I'm gonna stick with that. And this is the basics. Till next time.